All right. Thank you very much. I am Haemin. I'll be talking about relations today. And let's just get started. So why should you care? Like, what is this thing? So I just discovered while working on some projects there are some additional knowledge that exists in an applications domain that is mostly underused. They're like rarely used. And just wrote a simple library that actually can help you utilize this knowledge, and then how you can benefit from it, and then like you can benefit from it. So I'll tell you like what it is and how it actually works. So before we start, I'm just going to introduce the example domain of a service that I'll be using throughout the talk. That example domain is that of a rental bookstore. It's pretty simple. So if you have a rental bookstore, you would probably need a way to represent a book. So there's case class book is very simple. Just for the sake of example, you would also need a way to represent a user. So you have your case class user, very simple as well. And you would also have a case class rental that represents a rental object. And well, yeah, I think there's not a lot to explain here. I'm just going to pass on. And the funny thing that I discovered here is that there are relations between these domain objects that actually we utilize not as much. So let's put it down on maybe, sorry, what's going on? Aha. All right. So let's put it down on a graph, and then like let's discuss. Let's just see how it actually looks like. So for example, if you have a rental, you would have an associated book. So you would have a single book if you have a rental. So that's an arrow going from a rental to a book, like this. How about the reverse? Do you have a book? Can you have a rental? Well, turns out there are two ways to get a rental out of a book. So there is a current rental that is an optional relation going from a book to rental, because a book can be rented out or not at a particular time, at a given time. And so I marked it as a dotted line, and there's also the all rentals, which is marked as a dashed line. Is a dashed line because it's a many relation. If you have a book, you would have a many all rentals referring to all the past rentals that has happened to the book. Now, similar deal for the users as well. So if you have a rental, you would have a single related user, and for a user, you would have many current rentals, slightly different from the book. And you would also have many all rentals for a user. And also, there is this arrow that's going back to itself. I call them self. That basically means if you have a rental, you would have a rental. I'll explain how this is relevant in a moment. All right, so now that I've told you what is the thing that I found is a little missing from our Scala code base, maybe you use it in SQL, but that's not really Scala code base. So what is the way to represent these arrows in Scala? So this is what I've came up with. So this is the same case class rental that is in the domain, but I added 4 new case objects. So let's look at the bottom here. So there is case object book extends relation.single, and it goes from rental to book. So this represents the arrow that goes from rental to book that you just saw. Same deal for the user. And there's this thing called fetch that I didn't show you in the diagram, but it's an arrow going from a rental ID to a rental. So if you have a rental ID, you would have a single rental. It just codes that idea. And there's this self arrow that I told you about. How about different kinds of relations that are not single? So if you have a book, you would have an optional current rental that, because The rentals may or may not exist. So you would write it in a similar way, but just extend a slightly different one. All rentals, you would extend relation.many. But this many thing, you have another type parameter that takes a type constructor. It's a list. You're free to plug in something else, as long as it's a Scala collection thing. My plan is to add support for non-empty stuff like non-empty chunk if you use ZIO or non-empty list if you use cats effect. I mean, cats. Yeah, but it's not supported yet. And same for fetch and self. Not very interesting. So how are they useful? I'm going to sidetrack a little bit and talk about monomorphic functions. And monomorphic functions here, I refer to functions that doesn't have type parameters. All right, I'm going to ask you to help me name a function. So it's this function. So let me describe what it does. It takes a book ID and user ID, you can see that. And then it fetches both from the data source. So it fetches book and the user. It checks a couple of things, if the user can actually rent this book. And then if the user can, then it will create a rental object. It will persist the rental object, and they will return the created rental object back to the caller. And what would you name this method? Rent. Yeah. I would name it something like create rental or rent. So thank you very much. So I think this is pretty straightforward. Yeah. So I'm pretty happy with the name. And then the thing is, it kind of breaks when I add another thing. So here, the first one is the same thing that I just showed you, but the second one is slightly different. So it has the same behavior, but returns rental.webbook. And what is rental.webbook? It's just a tuple of rental and book. So it just returns also the book. And now this doesn't compile anymore because Scala doesn't let you overload methods that has the same method and the same parameters, but only differs in the return types. So it's impossible. So what I usually do when I'm faced with this situation, I'm forced to do something like this, and I don't really like that. Maybe some of you also share this feeling once in a while, I don't know. But why is this a little awkward? Like, why do I not like it? So let's take a slightly deeper look at what is in a method declaration. So in a method declaration, there is, of course, a method name that represents an operation. And so this is more like a verb. This represents an operation. The second one are the parameters that are the requirements of an operation. And they are pretty tightly related to the operation itself, because if you, for example, don't declare enough parameters, then you just cannot write the implementation of the method, like obviously. But if you have like more parameters than what is required, then you even have like compiler flags that tells you, oh, you have an unused parameter. So it's pretty tightly related to the operation. And but there is also the return type, and this return type is slightly different in the sense that it is related to the operation, but it's loosely related to the operation. What do I mean by loosely here is that it is valid for this method to return a rental and also rental.webbook. Like both are valid, right? But like a different parameter list would be invalid, but a different return type would still be valid. So a return type is only loosely related to an operation, so in my view. So then how does a concrete return type get decided? So that's the question. And the thing that makes a concrete return type gets decided is the call site, the requirements of the call site. So while it is not strictly required to return a specific type in a declaration, from the call side, it actually matters a lot what this function actually returns. So having these two names here, two different names here, is a very inefficient way to convey some information from the call side, what they want, to the method declaration and implementation side. How do you more efficiently convey information from the call side to the method? Very simple question. Just put it as an argument. That is how you normally convey information from the call side. So return types here as arguments to a function. And this is not a new idea. It is totally not a new idea. We already have something very widespread. So, GraphQL. GraphQL already requires a client to call a service with what they want back. They should indicate what they want back. So this is already an existing idea. And maybe I could fit something like this in Scala, inside Scala. And because GraphQL is all about runtime, right? It's about clients deciding at runtime what they want back. So we want something that's more compile time. So this is create rental method that I've showed you a little earlier. And what we want to indicate here is actually from the rental that was created by the operation, I want that rental back. So it is this traversal of the relation graph in this form. So from the operation, the imaginary operation, it creates a rental, right? And what I want to concretely return from it is itself. So I want to traverse it this way. How about the other one? So the other one, creates rental returning book, is a so the call side wants to indicate a traversal that looks like this. It's like a branching traversal. It's a tree type traversal. So from a rental, it wants itself, and from a rental, it also wants the book. So the call side only has to indicate this traversal to the method, and then the method will just give the call side back this data. I think I'm running out of time. I'm so sorry. I'm going to have to speed up a little bit. So originally, this is what it was, and now we have an additional parameter called relation. It's a reified relation from rental to A, and the A is opaque to the method. And now, to indicate this, what you do is actually pretty simple. It's value relation, it's relation.self, and then you call the method using this. So you just call relation.reify to make it reified relation. I hope I might have time to talk about what reified is later. I'm kind of running late. How about this thing? So I will show you how to combine this. These two relations is actually pretty simple. You just use this operator ampersand. So rental.self and rental.book. It models this traversal. And then what we have is with this method, you call it like this. So you have value relation, it's relation.self and rental.self and rental.book. And then you pass it in as an argument, and then you get a tuple of rental and book, and that's all compile time. You just have all the IDE, autocomplete stuff. Yeah. For slightly more complex ones, it also works as you would expect. So if you have 3 things, you would get a triple back. And for something that goes 1 layer deep, so from a rental to user, so I want the user from a created rental, and then I want to get all of the current rentals of the user. So if I want to go 1 level deep, you would use these, I would call a fallen Christmas tree operator, rental.user to user.current rentals. And yeah, you would get back a list of rentals back. But what if you also want the user back as well? Then you would slightly change. So this notice that the column points to the right. That only returns the right-hand side of things. If the column also points to the left, it would also return the left-hand side of things as well. So you would get a tuple of user and list of rentals. I'm so sorry, I don't have time to go through all of this, but these are the examples of like what you can actually express with this. And here, slightly more complicated. If I have a book ID, I can get a book object, and the user renting this book right now, and the list of users who rented this book so far. Think of it like how you would imperatively, like in ZIO, like with using flat map and for comprehension, how you would like write this to the actual database call. And this is how it looks like. So I get the book object here. The column also points to the left, so I get the book object. And then from the book, I get the current rental, and for the rental, I get the user. And for all of the rentals for a book, I also get a user for each of them. All right, so yeah, that's for the DSL, like only 3 operators that I've defined. And it's pretty much enough to express quite a lot of things. Now, the program still doesn't know how to actually go fetch the data from the data source. So let me show you how that is done. So for each relation to actually work, by work I mean be reified. So the reified call to actually be, like to compile, you would have to provide an implicit proof for every relation. So, you would have a rental val, implicit val, rental book impl, and then just call this special method, implement single data source, put in your relation there, and then you would implement it by implementing a function that takes many values of rentals, so a chunk of rental, then return an IO of some chunk of pair of rent. For each rental, you also return a book. So you could implement it using SQL, you could implement it using like whatever data source you have, client calls, whatever. So if you have the proofs, and if you have your relation declared this way, then you can provide your starting value like this, like line 6. So you have your relation, and you just call .toZIO, and then if you provide your starting value, then you would get the rental and the user and the book back. So that is pretty much it. All right, so a few things about this. Under the hood, this is powered by ZQuery, written by Adam Fraser here, like this amazing library. Supports batching, deduplication, and cached access to the data source. So just a quick, I kind of want to show what batching means in this context. So user the current rentals gives you back a list of rentals. And here, I want a book for each rental. So the data source actually accesses the data source, the data source is only accessed 2 times here. Instead of fetching the book for each rental, the data source batches access for the book, so there's only 2 calls for the whole thing. And if you actually just follow the common rules, each relation will make at most 1 call to the data source and no more. If you're using cast effect, it's also this Decrel library. I just said the name first. This library also have feature parity between ZQuery and fetch as well. So if you're using cast effect, you can just use that library as the verification data type as well. And it also comes with native support, so it's actually not interop. And the core module doesn't have any dependencies. So here, this is the repository that I just made public this morning. My goal is to have 5 more stars by the end of this talk. Yeah, and Lastly, there's one more data type that I want to show you about. If you're still typing, it's here. But this data type is a data access data type, and it's very widespread. Like everyone uses this data type, but it doesn't use a backing store. This data type doesn't use a backing store. It's a data access library. So I would call it data access from thin air. Can anyone guess what this data type is? Sorry, I couldn't really hear. The data type is your generators in your tests. So it's a data access library, but it's a data access data type, sort of, but it doesn't use a backing store. And it turns out that you can use the same syntax, same DSL, to compose your generators as well. So this example here, gen.user is a generator for user that you already have. And then you call .expand, and then you provide an arbitrary relation traversal in here. So I want the user back. I want to generate a list of rentals. And then I want, for each rental, I want a book. And then what you can do is you can just plug it into check. And then you'll just get the values out. So I think it's actually a pretty convenient syntax for generating values. But there's also another benefit here, which is that in the implementation of your relations, that is done not through ZQuery, but for gen, is actually, when you generate the values, it would have more context than just generating the values from the nodes. So you're generating values for the edges of a graph. So when you generate your values, you would have more information about it. So here, you can see gen.relation many, and then you plug in your relation that you want to implement for. And then you would have access to the user that would be generated. So this gen.rental can, when it's generated, it would have the consistent user ID for all of the values that are generated. And because this is current rentals, the return date should be none, right? Is because it is currently being rented. So the values that you generate out of it, that is generated from these relation compositions, they will be more consistent. So that is less boilerplate for your tests. And yeah, that's pretty much it. I am working at a company called SmartPay at Tokyo. I'm actually Korean, but I live in Tokyo at the moment. And we will be hiring soon next year. So if you're interested in fintech, living in Tokyo, or functional codes and great engineers in the team, come talk to me. And thank you very much.